Should I start, Magnus, or?
I muted myself accidentally.
Yeah.
Fantastic. So let's do a redo. Welcome everyone to SQL Friday number 100. Do you hear me now?
Yeah. Not anymore.
All right. So we start again. Welcome to SQL Friday number 133. This is the title is wrong on YouTube, so I'm going to fix that soon. We have Pieter Vanhoven. Do I pronounce your last name right, Peter?
Yeah, perfect. Yeah.
Peter is employed by Microsoft. He's a PM, and he is going to teach us whatever you can be taught in 60 minutes about Always Encrypted with secure enclaves. We just chatted here that security is a hot topic, so I hope you will enjoy it. If there is something you wonder, ask questions in the chat. Whether you're on YouTube or on Teams, doesn't matter. Just ask the questions and I will relay the questions to Peter. I will leave the rest of the introduction of the session and of you to yourself. So welcome, Peter. The stage is yours.
All right. Thanks, Magnus. Hello, everybody. My name is Peter. I'm a program manager in the data platform security team. That's the team that manages all the security features inside Azure SQL, Managed Instance, and SQL Server. And I'm the PM for two features. One is called Ledger, which we're not going to talk about today. That's all related to data integrity. And I'm also the PM for Always Encrypted. And yeah, I submitted this session for SQL Friday, so I'm happy to share all the information and the cool stuff about Always Encrypted with secure enclaves. All right, we have a lot to discuss today, so let's get started. First of all, a little bit. About the agenda. I'm going to share protecting data through its life cycle. So what are the other encryption technologies that we have? That's really in short. And then I'm going to explain about everything related to Always Encrypted. So what are the different versions that we have? How can you configure it? What are the things that you need to be aware of? I will also do a short demo on how you can implement Always Encrypted in Azure SQL DB. So yeah, plenty of stuff to discuss. Like Magnus said, if you have any questions, let me know in the chat. I'm happy to answer all the questions. All right, let's get started. So protecting data through its life cycle. What are the existing encryption technologies that we have? First of all, we have a technology called transparent data encryption, which is encrypting data that is at rest, meaning as soon as SQL needs to write something to the disk before it is written to the disk, we're going to encrypt it. And the other way around, if we need to fetch data from the disk, we're going to decrypt it before it's loaded into memory. So like it's said, it's transparent for your application. The encryption and decryption is done by the SQL engine itself. What else do we have is encryption of data that is in transit. It's really encrypting the flow between your application and your database, and that is done by transport layer security or TLS. Now, related to encryption and data in use, we created a technology a couple of years ago called Always Encrypted, which allows you to encrypt data inside your table, so data that is actually in use, while still having the possibility to do query processing on these columns. And that is what we're going to talk about today. So it's really encryption of data that is in use. Now, what was our motivation of implementing Always Encrypted? We wanted to enable our customers to confidentially store their most sensitive information in the cloud. So the customers, they can still be in control of their data while protecting their data to high privileged users. And what I mean by that is, perhaps I can give you an example. In my previous life, I was a database consultant, also here at Microsoft. So I went to several customers, and typically I got enough permissions to access the databases, so I could literally see all the information that was inside that database. And sometimes these databases, they just contain sensitive information. So you don't want to have that, like, everybody that has access to your database can also see the data, right? So you need to protect your data from unauthorized users. So even high privilege users like DBAs, domain administrators, me as a consultant, we should still be able to manage the data, but we shouldn't see the data, right? And that's one of the motivations why we developed Always Encrypted. So like I said, it also supports confidential computations, so we can still have query processing on encrypted columns. That's a real advantage that we have here as well. So what is Always Encrypted? We started our journey in SQL Server 2016. So that was the first version where we released Always Encrypted. It is still available in the later versions. It is also available in Azure SQL Database, in Managed Instance, and even in Cosmos DB, right? So what is the principle of Always Encrypted? So it's really client-side encryption. And what I mean by that is that the encryption and the decryption is done on the application side by the SQL client driver that is used by the application. So you should see that the application here is considered as trusted, and everything outside the application is considered as non-trusted. It means, so the network, your database engine, but also external people like DBAs, your operating system administrators. These are all considered as non-trusted. So how does it work? Now, if your client application wants to retrieve information from the database, it's going to send a query in plain text, but the client driver is going to encrypt that information. And it's going to send it in ciphertext over the network to the database engine. The database engine will fetch that information and will send it in ciphertext back to the application. It's going to be this client driver again that is going to do the decryption, and it will show you the information in plain text inside the application. So once again, client application is considered as trusted, database engine and everybody else that is outside the application is considered as non-trusted. So it's really the client driver that is doing all the work here on the client side. Now, with this first version of Always Encrypted, you had strong encryption, but you were quite limited to the number of you were limited to the flexibility that you could have with encrypted columns. For example, you could not use, or you could use an encrypted column in a where clause, but you could only use equality. So you could only say where encrypted columns equal a specific value. So this was not really flexible. You could not use joins unless you were using deterministic encryption type. So good encryption, but you were quite limited to the flexibility or the things that you could do with an encrypted column. Now we wanted to address these problems, and we created a better version of Always Encrypted, which is called Always Encrypted with Secure Enclaves. That is available in SQL 2019 and SQL 2022, and is also available in Azure SQL Database. So the principle is exactly the same. However, now the database engine can use a secure enclaves. And what it means is that, so when the database engine needs to do computations on an encrypted column, it's going to delegate that computation to a secure enclave. So inside that enclave, we're going to decrypt that information, and that can be done really safely because the secure enclave is, or you need to consider that as a black box, right? Nobody has access to it, not the operating system, no DBA whatsoever. So nobody has access to that secure enclave. So inside that enclave, we can securely decrypt that information and do the computation on that plain text. So this means by leveraging that secure enclave that we get now much more flexibility on encrypted columns. So you can now do rich computation queries on encrypted columns, meaning you can do pattern matching, like using like in your where clause. You can use range queries like larger than, smaller than. You can order by on an encrypted column. You can even create an index on an encrypted columns, which was all not possible with the first version, Always Encrypted. And the second advantage of using Always Encrypted with secure enclaves is what we call in-place encryption. Let's assume that you want to encrypt or do an initial encryption on an existing column in your table. In the first version, Always Encrypted, what we had to do is we had to extract that data from the database to the application, do the encryption there, and then push it back into the application. So that was really time consuming, not performant, and not even secure because we need to extract all the data from outside of the database. Once again, with secure enclaves, we don't need to do that anymore. So the data can stay inside in your database. And because we can use the enclave to do the initial encryption. Same for key rotation. You can now do key rotation inside your database without moving the data outside of the database. Make sense? All right. Any questions, Magnus, in the chat? If not,
Nothing so far.
No. All right. I'll continue then.
I might have
Cool.
one in
Okay.
terms of performance.
Yeah.
On an average workload, how much does Always Encrypted with secure enclaves cost? Do you have a number for that?
We did some extensive testing, and of course there is a performance impact because we need to encrypt and decrypt that information on the client side. How much that is really, really hard to tell because in SQL it always depends, right?
Yeah.
And same for Always Encrypted. So it all depends on how much data do you need to encrypt and decrypt. How much columns did you have encrypted and decrypted? What is the data type? What is your workload? So it's really hard to tell. So you need to test it, right?
Yeah.
You need to compare, like, this is the workload that we have without Always Encrypted. Now, what is the impact that we will see if we would encrypt 1, 2, even more columns in a specific table? So it really depends on your workload. It's hard to say, but will there be an impact? Yes. That is the consequence of having a security feature enabled.
True.
Make sense?
Yeah, it does.
All right.
We have one in the chat here.
Okay.
One question regarding Always Encrypted. Since Always Encrypted is a client-based application, and in our company we are the owners of client applications, backend and databases, and we're selling our services to customers as a software as a service, does it make sense to implement Always Encrypted in this case just to hide sensitive columns, since we are the owners of the client apps from high-privileged users like DB admins, etc.?
That's a good question. It all depends from who you want to protect your data. If you're saying everybody inside our company can be considered as trusted, fine, then you can actually implement Always Encrypted. If the client doesn't want you to have access to the keys, there are ways to configure the keys inside the database where, for example, where you don't have access to the encryption keys. So I'll come back to it later. With the role separation on when you want to configure Always Encrypted. So, for example, a DBA shouldn't have access to the encryption keys. Otherwise, the whole principle of Always Encrypted goes away, right? If everybody has access to the data, yeah, then it all goes away. So the same will count for this question. So it all depends from who do you want to protect the data.
Good, thank you.
All right. Okay. Cool. Let's move on. Now, what is an enclave? And an enclave, you should see it as an isolated region of memory inside your server or inside your database. So, as I mentioned, everything that is stored inside that enclave cannot be accessed from outside the enclave. So it's really a secure environment. Now, how can we guarantee that that enclave is that secure, right? And you have two possibilities to have that secure isolation of that enclave. So you have a hardware way to do it, which means we're going to configure an Intel CPU, so a physical CPU inside the server. It's called Intel Software Extension or Intel SGX. And the other way to do it is using a hypervisor. So it's called virtualization-based security or VBS enclaves. That is a service that is available in Windows 2019 and also in Windows 10. So you have the two possibilities to use. In Azure SQL Database, both of these enclave types are available. If you look at SQL Server, in SQL Server, so the box version, we only support VBS enclaves. In Azure SQL DB, we configure or we support both of the enclaves. How can you configure an Intel software guarded extension? You need to configure what we call a DC series. So the SLO that you need to configure is a DC series. When you select that, under the covers, we're going to create a virtual machine that is actually going to use these physical CPUs, these Intel SGX CPUs. If you look at VBS enclaves, there is no specific hardware needed. You just switch on the VBS enclaves and then you're good to go. So there's no specific hardware dependency here. DC series is only available in vCore model, while VBS enclaves is available in DTU and vCore model. The compute size is limited for DC series to 40 physical vCores. Again, in VBS enclaves, we don't have any limitation, so you can go up to 128 vCores. Also, the region availability is quite limited for SGX enclave, so it's East and West US, North and West Europe, East Canada, UK South, and Southeast Asia. If you need to have Intel and SGX enclaves in another region, where we currently don't have it available, reach out to me. I can help you with that. If there is a strong demand for it, then we can always enable extra regions. But if there's no demand, we're not going to do that. So where's the difference, right? When should you choose Intel SGX or when should you choose VBS enclaves? Well, again, it comes to what information do you want to protect it from who? Do you want to protect it, right? If you're saying, well, I just need to protect it from malicious insiders, well, then you can actually go for VBS enclaves. And the difference is that VBS enclaves does not protect you from the host attacks from the host OS. Perhaps bluntly said, but if you don't trust Microsoft in this case, then you should go for Intel SGX, because otherwise, VBS enclaves won't protect you from attacks from the host OS, meaning raw cloud operators and malware, right? Intel SGX does protect you from that. So sometimes, again, it comes to from who do you want to protect data. Sometimes I have customers there actually telling me we don't trust Microsoft. Fine, but then we still have a solution for you, and that is Intel software guarded extensions or Intel SGX. Okay. All right. A little bit more about attestation. So before an application or the driver submits a query to the database engine, it needs to verify whether that enclave that SQL is using can be trusted. And this is done by what we call an attestation, an enclave attestation. And that involves really the database engine that is going to submit a request to the attestation service, and then is going to get the evidence back that the attestation can be trusted, right? So in Azure SQL database, if you're using Intel SGX enclaves, you need to use also Microsoft Azure attestation. So it's a PAL service that where you have to configure an attestation policy, and inside that policy, you need to configure this specific rule. Now, it's all documented in the Always Encrypted documentation, but this is necessary for Intel SGX enclaves. For VBS enclaves, we currently do not support attestation. We're working on that, but for the moment, we do not support attestation. So the difference is SGX enclaves use Microsoft Azure attestation. VBS enclaves, there's no attestation available. For SQL Server, the box version, like I said, you can only use VBS enclaves, and here you have to use either no attestation, you can choose between no attestation or host guardian service. Once again, all of this is really in our documentation. Before I jump into a demo, maybe a little bit more about the two encryption methodologies that we have. We have deterministic and we have randomized. What's the difference? Deterministic means if there is a value in a specific column that is the same, right? Then we're also, the encrypted value will also be the same. If you choose randomized, then for the same value in that specific column, the encrypted value will be different. So here in the slide, there is an example for zip code, where you can actually see that if the zip code is the same, the encrypted value will also be the same. For randomized, it's going to be different, which means that randomized is a stronger encryption methodology than deterministic. Always encrypted, so the first version supports both of these encryption types. If you want to use always encrypted with secure enclaves, you always have to choose randomized. So you cannot use deterministic. That is not an option. That's not available. Okay. A little bit more, about these roles and responsibilities. So if you want to use always encrypted, you can configure it by one person, but then you need to really trust that specific person. But what we recommend is, especially in larger companies, is to have a role separation when you want to configure always encryption. And the roles are the following. So the DBA, that is a person that needs to configure always encrypted with secure enclaves. So it needs to, that person needs to configure the DC series, or it needs to enable the VBS enclaves. And the DBA also manages the metadata about the keys in the database. So the keys are never ever stored inside the database. We're just storing metadata that is pointing to the location where the encryption keys are stored. Yeah. Then the second person that comes into play is the security officer. That is a person that is going to generate the column encryption keys and the column master keys, and also manages the keys that are stored in the key stores that are containing the column master keys. So the key stores can be Microsoft Azure Key Vault or Windows local certificate store, or you can also use a third-party and key store if you should have available at your company, right? And then the last role that we can see is the developer or the application owner. That is a person that is going to encrypt the columns for you, that is going to configure the connection string to use always encrypted, and the developer, of course, is going to write the code to take advantage of always encrypted. All right. Maybe an example so that you have an idea. Perhaps this is quite technical, but I also wanted to share this with you. How an example of how the query flow actually is when you use always encrypted. So once again, on the left side, client side that is trusted. Right side is the Azure SQL database or SQL Server that's considered as non-trusted. The application is going to send this specific information, select name, social security number from customers, where social security number equals a specific parameter value, and that value is going to be 1122 and so on. So the first thing that the client driver is going to do, it's going to send, or it's going to handshake with the database engine to verify which columns are actually encrypted. And that is done by executing a stored procedure, which is called SP-describe parameter encryption, right? SQL engine receives this stored procedure, and it's going to return encryption metadata for these parameters. So the SQL is going to say, yeah, social security number is indeed encrypted. It will also provide metadata about the location of the column encryption key and the column master key so that the client driver knows where to fetch the keys, right? Once the metadata has been returned, then the client driver is actually going to send the same query, but this time is going to send the social security number in encrypted format. It knows this because it received that metadata. So it's based on that metadata. The SQL engine gets all that information, it gets or retrieves the query, executes it, and then is going to send back the name and the social security number. But the social security number is encrypted, so that is sent back in ciphertext. The client driver receives that information, and then it's going to decrypt it again and is going to show you social security number in plain text on the screen on the client side because that is trusted. So the key thing here is that also your application needs to have access to the encryption keys before it can encrypt and decrypt that information. All right. For a second, Magnus, are there any questions before I jump into the demo here?
No new questions, no.
Okay, that means that my explanation is fine. Okay, I'm going to do a short demo now on Always Encrypted with VBS enclaves in Azure SQL database. Now let me jump into the Azure Portal. Can you see my screen, Magnus? You should see the Azure Portal now.
I see the Azure Portal.
Okay,
yes.
Perfect. So for this demo, like I said, I'm using a database called Contoso HR. And if you go to security and you select data encryption, and then you select always encrypted, you can actually see here that I have an enclave enabled, and it is a VBS enclave that is enabled on my database. So that's the database. Oh, sorry. My apologies. What else do I need for this demo is an Azure Key Vault. So I'm going to store or I'm going to use a key that is stored in my Azure Key Vault. Forget about the auto-generated. So this is the key that I'm going to use, column master key, right? And here...
Would you be able to zoom in a little bit in
oh, yes.
Edge?
Sure. Is this better?
Yeah, thank you.
Okay. Now, to provide access to these keys, you need to, or you have two options, or you choose for access configuration. But in my case, I'm going to use the access control. And if you look at the role assignments here, then you will notice that here the Key Vault crypto users. So my application is going to, or it will have access to the keys, and also my login also have access to the keys. So I'm using the role Key Vault crypto user, right? Okay. Let me jump to the application itself. So I'm running here. Where is it? Yeah, here it is. So I'm running a web application. It's a simple web app, but what I wanted to show you here is my connection string. So my connection string, advanced. All right, so I'm connected to my database server and my database. And if you want to use Always Encrypted with secure enclaves, you need to provide the following extra parameters. So you need to tell, yes, I want to use column encryption setting equals enabled, means yes, I want to use Always Encrypted. And for the enclave, you need to specify also the attestation protocol. And as I mentioned in the slides, I'm using VBS enclaves, which we currently do not support attestation. So you need to specify none here. In case you should use Intel SGX enclaves, then you need to specify the attestation protocol MAA. MAA stands for Microsoft Azure Attestation. And then you need to provide an extra parameter, which is the attestation URL of your attestation service, right? Now, let me jump into the application. So this is the web app. It's a simple application that is used by an HR department. And as you can see, this simple web page contains lots of sensitive information. So we have social security numbers, first name, last name, and the salary. Now the application allows me to search also. So when I type in, for example, 99, I get all these social security numbers back that have that have 999 in it, right? So simple web application. Let me jump to the Management Studio now. This is the employees table here. And I am connected here below. You can see this, hopefully you can see this as a login called Azure Admin. That is a user that is used by the DBAs of the company. So if I just run this select statement here, I can actually see the same information like in the website, social security number and salary. And that's not what we want, of course. We want to protect that sensitive information from people that do not need to see this information. Now, there are several ways to do your encryption. You can use T-SQL statements, you can use PowerShell, but in the Management Studio, we also have a wizard available, and that's what I would like to show you. So if you right-click on the table, then you need to select Encrypt Columns. And that will start up a wizard for you. The first thing, oh, by the way, I forgot to mention that. Let me cancel this for a second. The first step that you need to do before you can configure your database with Always Encrypted is configuring the Always Encrypted keys. So you need to configure a column master key that is pointing to the key that is stored in the key vault. Let me show you this. So here you can see the keypad and it's actually going to my key vault, and I'm using here you can see that also CMK. Once you have configured your column master key, you need to configure a column encryption key. And a column encryption key is then going to encrypt your columns. So the column master key is actually your key in the key vault, and that is used to encrypt your column encryption key, and then your column encryption key is used to encrypt your columns. So that's how it works. Right, now let's jump into the wizard. So I'm selecting Encrypt Columns. First step that you need to do is you need to select the columns that you would like to encrypt. Well, I'm going for social security number and salary, and I'm going to choose randomized as the encryption type because I want to take advantage of the enclave. The encryption keys are already configured. If you don't have encryption keys, there will be a possibility here to automatically create an encryption key. So that is also possible. But I did that already in advance. So that's why the wizard sees these column encryption keys. All right, master key configuration. There's no additional configuration necessary because I'm already using an existing keys. I want to use in-place encryption, and the Enclave attestation protocol is none. Again, I'm using VBS Enclave, so I don't need to use a protocol. What are the other options? Like I said, Microsoft Azure attestation or host guardian service. In this case, I'm using none. The run settings, yes, I want to run it right now. Then I get a summary. Okay, these are the columns that I want to encrypt, and I'm going to use in-place encryption using that secure enclaves. Click finish. And now the Management Studio is going to perform the encryption operation on my columns here. That just takes a couple of seconds. Perhaps in the meantime, Magnus, if there are questions, let me know.
Yes, there are.
Right.
How does the client and server exchange the encryption key? And if I can add on, do you create the keys in SQL Server or do you create them outside of SQL Server?
Right. So the answer to the first question is that is done by that specific store procedure that I explained in the last slide. So the application is going to ask to the SQL engine what columns are encrypted, right? And what is the key that the columns are encrypted with. And that store procedure is going to send back encryption metadata to the client driver. So the client driver is then going to use that metadata to find the key in the Azure Key Vault, right? And of course, if the key has access to that key vault as well, then it will be able to encrypt and decrypt the information also from the application side. Yeah, so that's how the application and the SQL engine are communicating with each other. The second question is related to creating these keys. We're not going to load the key or the certificate inside the database. That's not what we're doing. We're just storing metadata to the location where the key is stored, right? And that's, yeah, so the keys are never ever stored inside the database. All right.
Cool.
Okay. Other questions, or can I continue?
Is the encryption key transmitted to the client in plain text, then only metadata about the encryption key is transmitted?
Yes, only the metadata about the key is transmitted, nothing else.
Cool.
Okay. All right. So in the meantime, the encryption is done, which means if I would run this query again as my login Azure admin, I can now not see anything related to social security number and salary. As you can see, this is completely ciphertext here, right? If I go back to my application now, and I just do a refresh here, just give me a couple of seconds because it just, yeah, need to reload all the information now. There we go. And as you can see, the application here still has the plain text. So we can still see social security number and we can still see salary. Why? Because as I showed you in the portal, this application or the managed identity of this application has access to the keys. So the client driver here is capable of encrypting and decrypting the columns. If I go back to my management studio and here I'm connected as my own login, right? Then I will also be able to see the plain text because my login also has access to that specific keys or to these specific keys. I can use pattern matching. For example, if I use like, right, on an encrypted column, that will still work. So this is the advantage of using the enclaves, which was previously not possible with Always Encrypted. You can use larger than, smaller than as well. If I use here two parameters, min salary and max salary, where the salary is larger than and smaller than, and it will also show you the result set in plain text. So again, another advantage of using Always Encrypted with the secure enclaves. All these where clauses were not possible with Always Encrypted here. All right, cool. Let me jump back to the presentation. And so, yeah, what are the supported operations for DML queries? Like I already showed you, so the comparisons larger than, smaller than, between, in, like, distinct. You can do joins. You can order by on an encrypted column, and that's twice the same. So sorry. So no, sorry, it's group by. So order by, and then yeah, group by as well is also possible on an encrypted columns. This is all available in Azure SQL DB and all available in Secret 2022. Only order by and group by is not supported in SQL Server 2019. It is also possible to create non-clustered indexes on encrypted columns if you're using the enclaves again. So that is all possible. What are the drivers that we support for the application side? So everything .NET related. but also GDBC, ODBC, and PHP are the drivers that we support for Azure SQL Database and SQL Server. So not only DB, for example, that is not supported. If you want to use Always Encrypted with secure enclaves, you will probably need to upgrade your driver to the almost latest version. I know by heart for ODBC, for example, it is at least 18.4. Again, this is all well documented. So I'll share the links at the end of the presentation where you can find all this information. The tools that you can use for key provisioning, as I already showed you, it's SSMS, so the Management Studio. You can use PowerShell to configure keys, and you can also use SQL package if you would like to use that to configure keys. In-place encryption can be done through SSMS, also the Azure Data Studio, of course, only if you're using T-SQL. We don't have the wizard available in Azure Data Studio for the moment. All right. Okay, that brings me almost to the end of this presentation. Some resources I would like to share with you. There is a blog post that explains in detail how Always Encrypted with secure enclaves works. There is our documentation. It's really advanced, so you have a lot of information there. We also provide tutorials, so that is used a lot by our customers. If they want to get started with Always Encrypted, these tutorials actually guide you step by step. What are the things that you need to do with screenshots, with scripts that you can use just to get started with Always Encrypted. Data Exposed, that is a YouTube channel as well, and a Microsoft how would I put it? Interviews that my colleague Anna Hoffman is doing with everything related to SQLs. And there is also an episode with me talking about, again, Always Encrypted with secure enclaves. We also have a security podcast where we have a podcast related again to Always Encrypted. And we also have a sample code available. So we created a very small application where you can use it to Always Encrypted. Also, the demo that I've showed you with the client web application is also available on GitHub as well. So you can download it and try it yourself if you like. Okay. I hope you learned something. If you're playing with Always Encrypted or if you're already using it and you have feedback for me, if you don't like something or if you like something, let me know. So this is the email address where you can reach me on. I'm happy to get your feedback if you would have something. Thank you so much for joining this session. Hope you've learned something. And maybe Magnus, if there are any further questions, let me know.
Yes, there are.
All right.
So first one is TempDB. Will stuff in TempDB always also be encrypted? I mean, with transparent data encryption, then TempDB is getting transparent data encryption. But if you store, I guess, column data from an encrypted column in TempDB for one reason or the other, could be a sort operator even that uses it. Will that also be encrypted?
Yes.
Okay.
Yes.
Patrick asks, are there any common T-SQL commands that are not supported?
Oh, yes, there are. In the documentation, there is a section of limitations. So there are, for example, a couple of data types that we do not support. You cannot encrypt a primary key, for example. You cannot use transactional replication if you have an article that is encrypted, for example. All these kind of things are not supported by Always Encrypted. So it is, again, in the documentation completely.
So that means if you're into the natural keys dogma, then Always Encrypted isn't for you, I guess.
Unless if you want to use it, but then you will, well, we don't support randomized on a primary key. What we do support is deterministic. But when you use deterministic, as we have learned today, you cannot use the enclaves. So then you are limited to just encrypt your column, and that's basically it, right? So yeah, sometimes there are customers, they have that issue. They are like, oh, we have indeed natural keys. We would like to, and the key, for example, is a social security number.
Yeah.
Then they have a problem. Yeah. Then they need to redesign the database if they want to use it. Yeah. That's a fair remark. Yeah.
I asked the questions. I could maybe check if I'm right about this. When you use an order by, will it be ordered by the actual value or the encrypted value? And my answer was if the service or person who runs the query has access to the keys, then it will be ordered by the real value, otherwise by the encrypted value, because
Correct.
that's
Yes.
the thing that is in the result set.
That is correct. Yeah.
Cool. I don't see any more questions.
All right.
So
Perfect.
I guess that's
Sounds
it.
good.
I think it was a perfect, perfect length to just get into the concepts of it. And
Yeah.
I think it's a really good idea to just download all run through the tutorials and test the source code. And by all means, don't start in production. And make sure you have a good understanding of where the keys are stored and so on.
Yeah.
I think
Exactly. Yeah. That's right.
I know clients who lost keys for transparent data encryption, like the service master key and so on, and they had to crack on the. I mean, it's not good.
No. Exactly. That's right. Okay. Great. Thanks everybody for joining. Once again, if you have questions in the future, let me know. I'm also on LinkedIn and Twitter. So, or it's not Twitter anymore, is it X now?
Yeah.
So yeah, if you need any help, reach out to me. I'm happy to help. Okay. Great. Magnus, thanks a lot for having me.
Yeah. Maybe I'll see you in a conference or something.
I'm going to SQL Bit, so if you're there, yeah.
I'm skipping bits this year because it's MVP Summit the week before, but
Yes.
I will try to go to the mastermind conferences in Belgium and Netherlands, and we'll see.
Okay.
Yeah.
Maybe we'll see each other around then, for sure.
Cool.
Okay. Thanks a lot, everybody.
Bye.
Bye-bye. Have a nice